Okay, I'm Charlie Chapman, and I'm going to talk about building a hyper-flexible backend-driven UI. Really what this is kind of a behind-the-scenes look at a new feature that we're building at RevenueCat. I'm from RevenueCat. Our booth is out there. We want to talk to you. Sponsor, blah, 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 money, money. But really I'm here to talk about, how we built a really extensive backend-driven UI framework, and hopefully how that can maybe apply to you. But before we get into that, let's talk about the real reason all of you are here today, which is me. I'm just kidding. My name's Charlie Chapman. I have been a software developer since 2008. I refuse to do the math on how long that's been. But I've been an iOS developer since 2019. So I've been doing this, I guess, for an actually decent amount of time now. And I've been at a series of different companies, but a surprising number of them I've built out backend-driven UI frameworks of different varieties over the years. And so I'm trying to bring some of that experience into this. I am from the United States. I'm from a city called St. Louis in Missouri. It's right in the middle. It's kind of the place you look down whenever you're flying between New York and LA. Most people don't end up there by accident, so don't worry if you've never heard of it. I'm also an indie app developer. So I make an app called Dark Noise. It's on iOS, iPads, on the Mac. If you go to an Apple store, it's actually pre-installed on all of the demo units. So yeah. It's like my one claim to fame. So yeah, you can go to the Apple store and look for the little Great Mac Apps folder, and you'll see it down there. And then my day job is I'm a developer advocate at RevenueCat, which is why I'm here today. So let's actually talk about backend-driven UI. And many of you may not have heard that term, or you've heard backend-driven development or something like that. So let's kind of define what we're talking about here first. So this is a UI. Let's pretend it's SwiftUI, because this is a Swift conference. And you have like a vertical stack. And this is cool that I can stand next to this. I like this. You have a vertical stack, and you have some rectangles, and then in here you have an H stack, and you have some rectangles. And it's all defined in code, in the actual binary that's shipped out to your users. A backend-driven UI is just that, but it's coming from a backend. So if you make a change on the backend, that change is reflected in your UI. The important thing here is most of you probably use some sort of backend to drive what content is shown. That's not what I'm talking about. I'm talking about the actual UI changing, the layout itself, which is a little bit more complicated. So why do people set up frameworks like this? There's a couple different reasons. So the big one is that you can change the UI without needing to do an app update. We all know how long we've spent trying to wait on app review to get something out that marketing is begging us for. But even once you get your code pushed out through the App Store, you have to wait for users to download that. And so it can take a lot more time. So one of the biggest reasons is just speed. The other big reason that I've come across a lot at bigger companies is the ability for non-engineers to make changes to your layout. A lot of times, especially marketing or growth teams, they want to be able to iterate or change things or run a quick sale or something like that. And getting engineering resources to change copy and button colors and how rounded your rectangles are, at least for me, is not the most fulfilling engineering work. And so sometimes it's hard for them to get engineering resources. And if you can build something where they can make those changes on the back end, they don't need to talk to you at all. It makes you happy, it makes them happy, everybody's happy. The other big reason is so you can send a different UI to different users. The really big use for this is if you're running A/B tests for doing experiments, so you can optimize layouts. This is a really big deal if you work in paywall land like I do, because optimizing your paywall to be the most effective directly affects how much money your company makes. And then the other one, this is other companies I've worked for, I've done this. You actually have a different layout based on specific details you know about that user. And so that's something that's usually on the back end. You don't want to have to bake all that logic into your app binary. And you want to be able to change it kind of on the fly based on an algorithms team or something. So the first thing I want to talk about here, and I apologize too. I'm the opening talk in a Swift conference, and it's actually pretty architectural, so a lot of this is going to be kind of high level, but hopefully it gives you ammo to push back on your architecture teams to kind of shape it so it makes more sense for you if you end up in this situation, because I certainly have ended up in this situation many times as a Swift developer. So I have this concept that I call the gradient of backend-driven UI. I think it's really important when you're in the beginning planning stages of building something like that. So to like illustrate it, this is a paywall. This is the biggest paywall I've ever seen, and I live in paywall land with my work. And so this is, a pretty standard UI. Most of this is pretty static, right? You have an image, you have some text, that kind of stuff. If you want to make this or define how this paywall looks on the back end, there's a couple different ways you can break it down. So the first is you can literally say, this is a paywall. This whole big thing is one big paywall. It's paywall number 1. And your backend can say, hey, I want you to render paywall number 1. And then you can create a whole new paywall, which is its own SwiftUI component that you build in your app discretely. And then your backend can say, now I want you to render paywall 2. So the backend, all it has to know about is number 1, number 2. There's not a whole lot of detail there. This is really easy to make, obviously, but it's not super flexible. The next kind of like more flexible version of this is you could define these, what I called modules at companies I've been at. So it's essentially like if you've made a feed, probably many of you have made feeds as part of your work. That's what these usually are. So it's a bunch of components that you hand code, but the backend delivers it as an array of objects that are shown. And that way the backend can completely remove one of these. It can change the order of how they render. So there's a little bit more flexibility in there. And then the last one is, it's kind of hard to read, I guess, on the screen, I'm realizing. But either way, you get the idea. This is where the backend controls everything. This is like if you're writing SwiftUI code or you're building a website, it looks like this, right? You have elements that are laid out. You need to understand the concept of this is to the left over here, this is to the right over here. And your backend needs to be able to define all of that inside of the object that it's handing to your SwiftUI app. And then your SwiftUI app has to know how to turn that into SwiftUI code that it can lay out. So this one's a lot more complicated. And so this makes the gradient of backend-driven UI. And the important thing here, and the reason why I think it's really important to think about this early is at the beginning stages of a project, it's really easy to look at this and be like, yes, we want this. Because if you're a marketing person, you want all the control possible. And if you're an engineer, maybe I'm just really weird, but this looks super fun to build. And if I can convince my boss to let me spend a whole bunch of time building it, that's awesome. And the building it part takes time. That's the obvious part. But the really, really tricky part here is the maintainability. We all have to deal with Apple updating SwiftUI every year. But imagine having to deal with Apple updating SwiftUI every year for a whole bunch of discrete components in a custom render engine. Essentially, you're building like Flutter or React Native, but driven from the back end. And that can be unbelievably complicated. And so unless you know that you have buy-in from your company to dedicate a whole team to this, I would not do this. This is kind of my favorite world to live in because it's very flexible, but it's a lot easier to work with. So now let's actually talk about RevenueCat. I'll try not to make this like a pitch for RevenueCat. Everybody already knows it's amazing and you should be using it, so I don't even need to do that. But it's important for what it is I'm talking about us building. So the whole point of our company is that we make subscriptions easy to implement. And the way we do that is we have an SDK that you can embed inside of your iOS app. We also support Android and Flutter and all those, but we're going to act like those don't exist in this room. And so you can put that inside of your app. Man, this is so visual. I like standing next to this thing. And that SDK talks to a backend that we have. And ultimately, the reason why you want to use these two is because now our code can handle a lot of the pain of talking to StoreKit or Google Play Billing, but StoreKit if you're doing subscriptions with Apple directly. So our SDK can talk to the the native Swift SDKs on your device. And then our backend is actually going to talk to App Store Connect or Google Play Billing, or if you're doing like web to app stuff, we'll talk to Stripe as well. And this enables us to, one, it makes your development job easier, but two, we have purchase information going into our backend. We have purchase transaction information that we can get directly from the stores. And that means we can collect all that information into our own databases. And so we have a dashboard, which is just our website, and that has a bunch of charts that, I don't know if any of you have indie apps and have used App Store Connect's charts, but they're amazing and great and awesome. But ours are even more amazing and great and awesome. See, I'm pitching. I can't help myself. But yeah, so that's part of what that is, the big thing there. And then we also, like, you can connect to your own servers with webhooks, and I can keep making this more complicated, but I've already wasted way too much time on this. So the main thing we want to focus on is we have a website, we have a backend, and we have an SDK that's embedded in your app. And based on what we were just talking about with backend-driven UI, you can kind of already see we have a way for people to edit something that aren't engineers writing code. We have a way to deliver that to apps, and then we have a way to render things inside of apps. And that's kind of where we're going here. So one quick extra little piece of information, just because it's kind of relevant here, is one of the big features that's popular for using our backend is for running experiments, like I talked about earlier. And the way that you do that is RevenueCat has this concept called offerings, which are just essentially a bucket that has the products that you can buy. So if your app has like a monthly plan and an annual plan, both of those will exist inside of like offering A. And so you can define an offering, and then you can define another offering, and then you can set up an experiment, and all this is on our back end, to send the app a different offering to like 50% of your users either way. And then you can run an experiment to see which one performs better. But so far what I've talked about is just we're telling them which things to render, but originally, the actual rendering of the paywall itself was up to the developers. They had to do that. They used our SDK to see what products to show, but we didn't render that for them. And of course, everybody wanted us to do that. So eventually, we did do that. This was a couple years ago, and this was RevenueCat Paywalls. We built this, it was a couple years ago now. And when we were starting to build it, we didn't know exactly how many people we were going to dedicate to it. We didn't know how popular it was going to be as a product. And so the direction that we kind of took was let's go with the more simple version. Because it's, especially with payment stuff, it's really important that we don't break things. If that happens, it turns out people get really upset when they stop getting money. So that was kind of the initial approach that we took. And so I only have 30 minutes. I was going to do a bunch of live demos, and every time I practiced, I was way more than 30 minutes. So I've recorded everything, but I recorded these last night, so it's basically a live presentation. So this is Paywalls V1. So the way it worked is you could go through, and there was a whole bunch of templates that you could choose from. Similar to kind of what I was saying in that example on the gradient is you can pick between template number 1, template number 2, template number 3. Whenever you click on one of those, it takes you into our paywall editor. And inside of the editor, you could make a whole bunch of customizations to that template. So you can change the colors, you can change which image is showing, obviously which products are actually optional to buy. And like if you have a bunch of features, I don't remember if I did it, I didn't do it in here. But if you have a bunch of features, you can define a whole bunch of different features that you want to show in your paywall. And so it was pretty flexible as far as copy that you could put in there. But if I didn't want this title to be here at all, or if for some weird reason I wanted my features to be above the title, you couldn't do any of that because each of these templates is kind of a static thing. There's just a bunch of customizations that you can make to it. So if we look at the actual architecture here, the way it worked is our backend would send a paywall JSON file to our app. And then our app used that to render the actual paywall. And so this file was essentially a paywall name, and that's what drove which paywall gets rendered, and then kind of a bunch of metadata. So this is an actual like simple example of one of those JSON files. And so you can see, wow, it's like really at the bottom. Sorry, everybody in the back stand up. But down here, it's just the template name right here. It just says number 1. And that's the thing that decided which template would show. And then at the top, there was a bunch of configuration options like colors, which image should show, that kind of stuff. And then if I had more time, I would love to go into how we did localization, because that was a big bear. But a lot of localization information would also be embedded in this JSON file. And so this was the sort of render flow. Basically, in SwiftUI, once you got a hold of this JSON file, you'd deserialize it, obviously. And then you'd say, all right, if it's template number 1, render my SwiftUI component template number 1. And you'd hand it that metadata so it knew which colors to pick and which copy to show. But for the most part, it was a one-to-one relationship with components. So template number 2 renders template number 2, which is a SwiftUI component, and so on and so on. And this worked actually really well. It turned out this feature was really popular, and fortunately, this was really reliable. And the team that we had building it could at least keep up with it in terms of keeping it from breaking and not having a whole lot of bugs. But the problem was, as I'm sure even just looking at this, many of you were like, I wish I could make a template that looked like this. So everybody was asking for unique new types of templates. And every time we wanted to add a new template, we had to actually create in code a new SwiftUI component that was custom made for that template. It takes time, and that's a pain. But the really big pain, as everybody here that's an iOS developer knows, is backwards compatibility. So if I added template 4, I'd have to build template 4, a new component in SwiftUI. I would have to add some new logic to determine should I render that or should I not render that. And then I could ship that out. It looks great. Everybody loves it. A bunch of my customers really like it. They update their SDK, and then they push an app update out, which eventually gets through app review. And then some of their users update their apps. And so now there are some apps out there that have our new SDK. And so eventually they make the decision, all right, I want to create a template and actually publish it to the world using template number 4. The problem is there's still a bunch of users out there that never update their apps. And those users, what are they supposed to see? Because that version of the SDK has no idea what template 4 is, because it was all baked into the code itself. And so we had to create some backup paywall concepts that they were OK. They kept developers from ever having an app out there that users couldn't buy something. But the backup was really generic, because it had to be baked into the SDK. So once we proved out that the first Paywalls was really popular, we were like, all right, we're definitely going to commit to this. Let's grow the team really big, and let's build the version that everybody's really asking us for. And that is where we get to Paywalls V2. Speaking of the big team, this is a good time to point out, I'm not actually on this team. It's kind of a running joke at the company that my job as a developer advocate is to just look around the company and look at all the cool stuff other people build and be like, ooh, that's cool. I'm going to go take credit for that. And then I make videos and I stand in front of people and act like it's something I did. But I'm not part of this at all, other than me bugging them and asking for features. So these are the real heroes here. Most of them are engineers. We have Barbara's our designer. Dan's our product manager. So we have a team of people dedicated to making this happen and keeping it maintained long term. And so what are the main goals? Well, like I said, everybody was asking for more templates. That's the big story. But even within those templates, they wanted more flexibility. There we go. That was, somebody changed something on the, there's a joke there, and I couldn't find it. So we're just going to abandon that. Just back that up. All right, so people wanted more flexibility within those templates as well. And that's what people were asking for. But really what people wanted is they didn't want a new product with new options. They really wanted to build a specific paywall. And they just wanted us to make it possible for them to do that. And the current version couldn't do that. So the more we talked about it, the more we realized, as much as that's nice, we got to go turn it up to 11. We got to go all the way and make this truly a fully customizable UI framework driven by the backend for developers to be able to build whatever they want. So that's what we did. This right here is, like I said, I recorded this last night, so it's mostly real. But this isn't released. You guys are probably some of the first, certainly the largest group of people that have ever seen this live. We've obviously shown some people here and there. I think our CEO has tweeted teases about it, so you have that going. But yeah, this is it. So it's kind of hard to read some of the text, but this probably looks familiar for anybody who's used modern design tools, and that's not on accident. And you notice that the middle is completely blank, and that's because whenever I open this, I didn't start from a template. I started from scratch. And that's because you can build it from scratch. So here is a time lapse of me making a really beautiful backend-driven UI paywall with our new editor. And you can see, like, this is all being built completely from scratch. It's kind of hard to read over here, but some of this will look really familiar to you. This says stack. There's text. There's a footer. Like, this was built by iOS developers, and it feels like it was built by iOS developers. Ultimately, you can build basically anything you can imagine for the most part. And what's cool about all this is, you can build this, and this is a website, obviously, so non-developers can build these. They can hit save, and if you're using our SDK to render this, it's being rendered as SwiftUI. This isn't like opening a web view or anything like that. This is like a legit, normal, native application that's being run through our pipeline, just like V1, but way more flexible. So let's look at how the architecture's set up for that. It's actually really similar. So this was V1, and we had a backend that sends the JSON file over to the app. And in the new version, there's a backend that sends a JSON file into the app. In fact, if you're using Paywalls V1 and you update to V2, you don't have to change your code at all. It all works exactly the same from a usability perspective. The big difference is the actual JSON file is totally different. So before, we had like a template type, and that's what kind of drove everything, and then a bunch of like customizable metadata about it. Now we have an array of these objects that we call components. And some of these components have inside of them an array of objects called components. So ultimately, what you really have here is a recursive tree of components that could define your entire layout. So I'm not even going to bother going through these because there's no way you can read this. This is what the JSON looks like. It's extremely pretty. Just imagine it's beautiful and makes you weep tears of joy. Oh, wait, I did zoom in on it. Well, there you go. So yeah, you can see inside of here, there's this thing called a stack. And inside of the stack, there's components. And inside of the list of components, you have a list of components. This one is of type text. And there's a bunch of metadata then inside of those little sub-pieces of components. So yeah, I'm just going to zoom through these because it's honestly not that interesting. All right. So let's talk about the actual components themselves. So there's actually 3 building block components. They're the core components that define basically everything in our paywalls. There's a text component, there's an image component, or an icon. We have some sort of like SF symbols, some pre-made icons that you can choose from. But ultimately, that's an image. And then there's a stack. Stack is exactly like stacks in SwiftUI. They can be vertical stacks, horizontal stacks, or stacks in a z-index. And that covers almost everything. So everything that you saw in that whole layout can be defined with these 3 types of things. Stack is the sort of magic one because a stack can contain other components. And that's where you can start building really complicated layouts. There's also objects that we call container objects. And these actually are also stacks. They're just special stacks. So a button is a stack that you can define an action on. So right now, buttons, like you can open a URL, you can deep link to somewhere else inside of your app, something like that. There's also a package, which is the actual products that you can buy on a paywall. Whenever you tap on a package, it doesn't do anything, it just selects it. So that's what that special type of container object is. And then there's a purchase button, which is just a special type of button that initiates a purchase of whichever package has been selected. But right now, in the beta version that will come out sometime soon, this is everything. and yet you saw like how much flexibility there was in that layout engine. Oh no, that's good. I thought it was cut off at the bottom. So this is the new like render flow. So before we were just looking at each template and then sending you down to a discrete SwiftUI component. Now it's totally different than that. So the first thing we do is we deserialize the JSON into Swift objects, obviously, using Codable. And then what we do is, before we start rendering anything, we traverse through the entire tree of those objects. And each of those objects, we convert them into view models for two different reasons. The first reason is it's a lot easier. We change a lot of the data to make it easier to work with in SwiftUI. So like our colors are defined as hex values. We convert those over to like color objects, things like that. But the other thing is we can determine each component whether or not it's valid. And if we run into any components that are not valid when we're doing that initial tree traversal, we say, you know what, we can't render this. And that's where we do what we did in the old V1 paywalls. We render that hard-coded backup paywall. And that way, again, we have a way out. Nobody's ever going to try and open a paywall and it just errors out and they don't see anything. People can always give you money. That's the important thing. But if it is valid, then we start traversing that tree and we render each component one by one. So I've talked about it a couple different times, but backwards compatibility is the biggest challenge of this type of project. It's a big challenge for any iOS app, honestly, that uses some kind of backend. It's just something we always have to deal with. But it's especially important for something that does layout. And that's because you have kind of three different versions that you have to deal with at all times. There's your web API version, and that version is always up to date. It's always the latest version. The moment it changes, everybody gets that same version. Then there's your app version. In our case, the SDK itself could even be old inside of somebody's app. But essentially, it's like the version that's running on users' devices. And then there's the version of iOS that they're running. That's really important for a layout engine because, especially in the early days of like SwiftUI, things were changing a lot, and just basic building blocks could change on you. And that starts creating some really big backwards compatibility headaches. Luckily, SwiftUI, especially the basic stuff, is a lot more stable now. So we don't think that's going to be too big of an issue. But like I said, this is unreleased, so our engineers are probably sweating bullets, but I think they got it. So there's a couple interesting things, though, that we did for backwards compatibility that I think are worth mentioning, because I think this could be useful for other people building something similar. So the first is that we try to create everything with those core building block components. So text, image, and stacks. Those three components are going to be in the very first version of even the beta that we release out into the world. And so what that means is if we come up with an idea for a component that we want to release, that people want, that lots of people need, like a feature list or something like that, if we can define that with those core building blocks, we don't have to update the SDK. We can do all of that from the back end. We can build it into the editor, but we don't actually have to update the SDK, which means as soon as we release that out into the world, every old version of everybody's app also can get those, which is a really big deal. The other thing is we have this idea called component fallbacks, and I have 1 minute and 20 seconds left, so apologies for fast talking. So if the render, while we're going through the render, if it runs into a component it doesn't know about already, then it's going to check for this optional object that we have on every component called a fallback component. And what that means is if we have a new type of component, like a video component we want to add in the future, and we have to build a discrete type of app or a component for that in SwiftUI, old versions of the SDK won't know about it. But we can add this fallback component in there that uses those fundamental building blocks, and that will render if you're on an old version of the SDK. So you could build a fallback that just renders an image that's a thumbnail of that video, for example. So that's like kind of our basic idea there. And then, of course, there's going to be issues with iOS updates, and we're just going to have to deal with those like we deal with everything with our SDK, which is lots of good documentation, tell people that they need to update their SDK, and lots of fallbacks. OK, look at that. 10 seconds to spare. So this is me. I would love to do a live demo of all this, but like I said, with the 2 seconds I have left, I don't think I could fit that in. So come out to the booth, and I will show you. I'll let you use it. It's really cool, and I will talk about any of this stuff if you want to. All right.